Now we want to look at amplitudes. Ah, yes. So when we talked about amplitudes before, we said, well, a wave is a disturbance, right? And if it's a string, it deflects up at some. That's not so bad. It deflects up at some amount of centimeters of a string, and if it's a pressure wave, what does it do? It has some amplitude of pressure. But when you look at these two things, do you say, oh, it's a 10 volt per meter light bulb, right? You don't think about the field amplitude. Or, if it's a magnetic field, you don't say, oh, it's a 5 Tesla light bulb. Right? You say watts, right? You think about power of a wave in terms of watts. And here, you don't say, dude, these stacks will create a differential pressure amplitude of 200 pascals, right? You don't say that. You say watts, right? Both of these are in watts. So we clearly don't use the freshman physics version of amplitude. Right? We use other things. So let's talk about what the other things are here. Let's see. That was totally worth it. I mean, that was like critical to show those pictures. I could have had, yeah. Okay, so the kind of amplitudes we're going to talk about are power, intensity, and decibels. Okay, power. That's what we care about, power. Intensity and decibels, which are the most confusing thing in the world. It's like one of those things, it's like phase. People are like, oh yeah, dB. Yeah, 20 dB shift. I know what that means. So first let's remind ourselves what a wave is. So a wave is not quite what I said before. Another way to look at it. So before I said it's a disturbance going through a medium, but you could also say it's the transfer of energy through the medium. Because after all, that is what the disturbance is carrying, of energy through a medium. And it's kind of interesting if you think about it. For any wave, the medium doesn't move. Right? When the string wave goes this way, all the string is doing is going up and down with certain relationships. And when a pressure wave goes, each atom might do this a little bit. But when a pressure wave goes through the air, the air isn't all moving this way. Right? The only thing moving that way is energy in the form of vibrations of the medium. So the same thing is true for light. That the electric field doesn't move somewhere, it just gets tweaked a little bit. Okay, so that's what wave is. So then what is power? Power is the rate of transport of energy. And we talked about power before, you know what I mean. It's how many joules per second go through. All right, so if you have a certain number of joules, then this would be in watts, joules per second. So we could calculate the power that a string wave carries if we wanted to. We could calculate the power in a sound wave. Those are detailed calculations we don't really do. We could, but we don't. And then another one, though, is intensity. So this is, unfortunately, the less clear one that you have to think about. Okay? It's the power per unit area on a surface. Area on a surface. It's I for intensity in your book, and it's in watts per meter squared.